In lesson number 4 in Unit 1, we're talking about making a perpendicular bisector, which is a very important construction, not just to do by itself, but it helps us do other types of constructions in the future. On the first page of this lesson, the bottom just gets into some important vocabulary again. A right angle, as seen in the diagram, is any angle that measures exactly 90 degrees. That little box that we put in the diagram is meant to show that the angle is 90 degrees, so please copy that down. I'll leave the screen up if you guys want to pause it to copy down any of these diagrams. So in order to construct a perpendicular bisector, first we're just going to go over the definition of what that is. A perpendicular bisector is just a line that is perpendicular, which means forming right angles, to a certain segment, and it passes directly through the midpoint of that segment. So basically, on the segment we have here, for example 1, segment AB, we need something that does two things: forms a right angle and perfectly cuts AB into two congruent pieces. So for the first step, we're going to put our compass on point A, and for the pencil, you have the option of either putting the compass all the way on point B, or just moving your compass point halfway or past the midway point of the segment. So I'll go closer to B than to A. I make basically a semicircle going up and down. I'm going to remember which hole I used in the compass and flip my compass over and do the same exact semicircle using the same hole in the compass from the other side. Centered at B with my pencil closer to A. Those two marks now create two X's, and for those two X's, if I connect those dots, that purple line is a perpendicular bisector, which again means a few things. First, I can put a little right angle symbol there because perpendicular lines create right angles. And second, these two smaller segments now, from A to the middle, and in that middle, I'll just put a little point called M for midpoint. Those two different segments are congruent because of the bisector part of this definition. In our next construction here, we just analyze some of the things that are true about perpendicular bisectors. So on our page here, for example, they ask us some questions about different pairs of segments. So if I just look at the first one, because it's really the same for all three of these, the distance between A to C, and again, when I say distance, I do not mean use the ruler. I mean in my compass, the distance from A to C is going to be exactly the same distance from B to C, and the compass kind of checks that out. Basically, what that tells me is any point on the perpendicular bisector is going to be equidistant from the endpoints of the line segment. So from D to A and from D to B will be the same exact distance, and the same is true from E to both endpoints. On the second half of this page, we're going to practice doing a perpendicular bisector one more time. So you're going to need to draw in some segment. It's probably better practice to do a diagonal line just to get used to it. So in order to cut this segment in half with a perpendicular line, again, we're going to put the compass point on one endpoint, and we're going to go past halfway with the pencil of the compass. Semicircle halfway up and down. Remember which hole you used in your compass, and you're going to do the same thing from the other side. Half circle on one side and the other. And just like before, I'm going to connect those two X's, and that pink-purple dotted line is our perpendicular bisector. Little right angle tells me it's perpendicular, and those two little slashes tell me that that segment was bisected. In example 3, we have an angle here, angle ABC, and they want us to analyze some of the things that happen when we draw in an angle bisector. So I'm going to uncover this little purple box here that shows the work I did to make an angle bisector. Now for this angle bisector, we can see if we connect any 2 points for example, D and C, the line that connects those 2 points is actually perpendicularly bisected by that angle bisector. So those 2 little black lines are actually congruent, and they are perpendicular to that purple line, the angle bisector, going right through the middle. Same thing is true of the segment connecting A and E. The perpendicular line lets me draw in that little box there, and because they are bisectors also, AE is cut in half by the angle bisector. So again, the notes regarding the construction we just made, I will open up for you guys. And that is the end of lesson 4.